Hey guys, Mr. Lloyd here. Going to work with you today on Wednesday, May 20th. It's a little gloomy out today. There's a little bit of rain, drizzle coming down. It rained a bit last night. And good day to do some math and square away our thinking. So on this video, we're going to be going over both pages for the day. Today's math assignment was a little bit shorter than usual. This is just kind of a review today of concepts of mean, median, range, and quartiles. So different ways we can think about data, different ways we can organize data. Basically, think of all of those items, mean, median, range, and quartiles as different tools we use to understand data and make sense of what we're looking at. So a lot of explaining today, not a whole lot of, in fact, no calculation really, just some explanations and some little bit of writing is what we're going to be doing today. So let's take a look at it. Let's get into it. The review here is just asking us to fill in a couple of finish up a couple words. So quartiles are used to divide a set of data into equal parts. Each quartile has the same number of data values. That's it. I mean, that's all we have to do on that first part. So let me just jump in. Since the page is already on the screen, I'm going to jump into the challenge problems. So I've color coded them here. The purple one is down here in purple. The middle one in green is the middle one in green, and then the bottom one is black down here. Okay. So let's take a look here. The purple one says, what's the median of a set of numerical data? When is the median, excuse me, of a set of numerical data a number in the set? So what they're asking is, there are times when we find the median, we just point to the middle number, we can like circle it and say that's the median. And then there are times where we have to calculate the median because the median falls in between two numbers. And so what we're asking you to do here, when we wrote this question, we were thinking that you would think about sets of data that have odd numbers of values and sets of data that have even number of values. And so when a data set has an odd number of data values, the median is one of the values that's already included in the data set. You don't have to calculate anything. So the example here, I just created a data set including the numbers 4, 5, 6, 7, 8. They're already listed smallest to largest. And to find my median, there are 5 numbers in the set, 5 values in the set, and I just find that middle value, which is 6. So there are 2 numbers to the left of 6, 2 numbers to the right of 6. So that's my middle value, and that's all I have to do. You could create a data set that had 101 numbers. It'd be a huge data set, and the middle number would be your median. So anytime you have an odd number of values in a data set, your median is included. Okay? Let's look at the green one here. The green one says the mean and median of a set of numerical data are measures of the center of that data. And then it asks us, is range also a measure of center? And give a reason to support your answer. So it's telling you something that's true and important. Mean and median are measures of center. Range measures variability, so we take remember to calculate range, we take the smallest number and we take the largest number and we subtract the difference, we find the difference, and we get whatever value comes up, that's our range. So when we think about the center, mean gives us everything is leveled out to a center, and the median is just the middle point in the data, so those both measure center. But range measures something else. It measures the width of the data or the scope of the data, if you want to think of it like that. The other thing I thought about is the depth of the data, which might just be another word we could use to explain what range tells us about data. But range doesn't really tell us about the center. It tells us about the boundaries of the data, the smallest and the largest, but it doesn't really tell us about the center. Okay? So that was the answer to the green. Let's take a look now at the black. This black question says, for any set of numerical data, where are the first and third quartile numbers in that set? Okay, so this one, what we want you to think about here is when you're looking at a data set, let's look at this one here, 4, 5, 6, 7, and 8. The way we find our quartiles is we first find our median, which is in this case 6. So that's that middle number 6. That's the median. And then to mark our quartiles, we want to find the place in our data visually where we would have. So sorry, let me back up. We found our median, which was 6, and by finding the median of 6, we have now we've now divided the data into two groups. One group on the left, which is the numbers 4 and 5, and one group on the right, which is the numbers 7 and 8. And if I'm trying to find the first quartile of these numbers, I need to think visually about where I would draw my line, my dotted line, my little arrow, however I'm going to mark first quartile. I need to think about that. Where would it fit? And it would fit perfectly in between 4 and 5, because once I make a mark here, now I've got first quartile, which includes the number 4, the second quartile, which includes the number 5, and similarly over here as well. We'd mark it in between 7 and 8 would be our third quartile. And so when I'm looking at that, to answer that question, for any set of numerical data, the first and third quartiles are equidistant apart from the median. In other words, you find the median, and then the first and third quartile have to be, because they're dividing the data set into equal-sized groups, they have to be equally distant apart from the center. So that's what we were kind of saying, we're hoping you get to right here. Equal distant away from the median. The first quartile, of course, is on the left, and the third quartile is on the right. Okay, so that's the challenge problems today. And now when we go over to the other page, it's just a couple of questions about our friend Puzzle Penguin, always getting herself into some trouble here. So let's take a look at the top question here. Here is a data set. It's listed already, smallest to largest. Let's see what Puzzle Penguin's got going on. Can use mental math to calculate the range and the median of the numbers at the right. The range is 60 because 70 minus 10 is 60. Let's take a look, verify. 70 minus 10, sure, yep, it's 60. No problem there. And the median is 30 because 60 divided by 2 is 30. Is this correct? 60 divided by 30, no, not sure why Puzzle Penguin chose that method, but that is not correct. So let's get to the answer. The range is correct, but the median is incorrect. The median is found by listing the data from smallest to largest, which is already listed here, and then finding that middle value. So the middle value here, 40, perfect. For this data set, the median is 40. So just kind of going a little too far with this calculation. I'm not sure what Puzzle Penguin had in her head when she was doing this one, but just listing it, and because there are an odd number of data values in this one, we don't have to calculate anything. It's just simply 40. So that's it. Okay. I was asked to calculate, here's the second part. I was asked to calculate the first quartile of the set of data that's shown on the right. To calculate the first quartile, I divided the range by 4, like this. So range divided by 4, 10 minus 2, okay, that is the range. 8 divided by 4, and then Puzzle Penguin came up with the first quartile is 2. And that isn't correct, okay? The way we find the first quartile, we find the median, which is right here in between 4 and 6, and we know that number is 5. So the median is 5, and it divides the data into a left half and a right half. The first quartile, then, I'm going to visually look and think what number would divide the left side into two equal-sized portions. Well, in this case, it's the value 3, because it divides this left side into these two numbers 2 and 2, and this right side into these two numbers 4 and 4. Similarly, the third quartile does the same thing. It's 8. It divides the right-hand side of the data into two equal-sized portions, 6 and 8, and 8 and 10. So, let me back, yeah, there we go. So the first quartile in this case is 3 for this one. And remember, the quartiles are just a way to organize data to make more sense of it. It's helpful to know when we're trying to rank things, like if we're ranking basketball players and how many points they score per game. Is Steph Curry in the first quartile of points per game, the second quartile of points per game, the third quartile of points per game, or the fourth quartile? So those are just a couple of questions where we help Puzzle Penguin get her thinking straight and help her out with her understanding of statistics. All right, so that's all we're going to do today. We just are cleaning up some thinking, doing some explaining today for math, not really any calculation, just explaining a couple items to Puzzle Penguin and doing a couple challenge problems. Thank you for watching this video. Please continue to ask your questions through our Zoom chats, through text message, Remind app, email, phone calls, Google Classroom comments, lots of different ways we can be in touch during this time. Keep working hard out there, guys, and I will see you guys later. Thanks. Bye.